Welcome to Summarize Science, where we break down the latest research for you. We've all taken photos that came out blurry, dark, or had something we wish we could remove, and fixing them can be a real challenge. But what if an AI could not only fix your photos, but also edit them in creative ways, all without needing to be specially trained for each task? This paper, titled Test Time Anchoring for Discrete Diffusion Posterior Sampling, introduces a powerful new method to do just that. Just look at what their method, called Anchored Posterior Sampling or APS, can do. It can take a low-resolution image and make it sharp, fill in large missing parts, and remove different kinds of blur. It can even perform complex creative tasks like changing the style of a piece of clothing or applying an artistic style from a reference image. The AI model used here is a discrete diffusion model, which is a bit different from the ones you might have heard of. Instead of thinking about images as a smooth canvas of pixels, it thinks of them as being built from a collection of discrete blocks or tokens, almost like building with Legos. This approach can be faster and offer finer control, but guiding it to solve these inverse problems has been difficult until now. The researchers developed two key innovations to make this work so well. The first is called quantized expectation, which is a clever way to give the AI clear guidance on how to improve the image, even in this discrete token-based world. The second is anchored remasking, a smarter way to reconstruct the image. Think of it like solving a jigsaw puzzle. Instead of randomly filling in pieces, this method identifies the most important anchor tokens first, like the corner pieces or a person's eye. By getting these anchors right early, it becomes much easier for the AI to accurately fill in the rest of the image around them. And the results speak for themselves. In side-by-side comparisons for tasks like making images sharper, their APS method consistently produces cleaner and more detailed results. For instance, you can see how it reconstructs the fine strands of the dog's fur, a detail that other methods struggle with. The technique also excels at creative tasks that go beyond simple restoration. Here, it successfully applies the style from a reference image, like this celestial artwork, to a completely different photo of a carousel, creating a unique, stylized result. Perhaps the most impressive demonstration is this text-guided and painting task. A part of the image is blanked out, and the AI is told what to draw through a text prompt. The prompt asks for the shirt to be buttoned all the way to the top, and remarkably, their method is the only one that correctly follows the instruction, outperforming major models like Imagen 3. So let's recap the important takeaways here. The researchers have developed a new training-free method called APS for discrete diffusion models. It uses two core ideas, quantized expectation and anchored remasking, to intelligently guide the AI in restoring and editing images from incomplete data. This allows it to achieve state-of-the-art results among similar models, often outperforming even more complex continuous diffusion methods. What does this mean for the future? This work establishes discrete diffusion as a practical and highly effective alternative for posterior sampling tasks. It could lead to significantly faster and more powerful AI tools for photo and video editing, and opens up new possibilities for multimodal AI that can seamlessly blend text and image manipulation. This represents a major step forward in creating flexible and efficient AI that can understand and reconstruct our visual world with incredible accuracy. Thanks for watching. If you enjoyed this video, please like and subscribe to Summarize Science for more breakdowns of the latest research.